Presenting my poster about the development, characterization and application of a hyperspectral imaging system to monitor hemodynamics and metabolic states of the exposed cortex. So hyperspectral imaging is an imaging technique that acquires images at multiple wavelengths in the visible and near infrared range, and by using this approach theoretically it would enable us to measure not only changes in oxyhemoglobin and the oxyhemoglobin in the brain, but also to measure the redox stage of cytochrome C oxidase, which is a biomarker for brain cellular energetics. So I've developed a hyperspectral benchtop system that uses two illumination platforms. One is a supercontinuum laser with acoustoptics tunable filters that can acquire multiple wavelengths in the visible near infrared range between 450 and 900 nanometers. And the other illumination platform is that uses a white light broadband source coupled with a rotating motor and a Pellini-Broca prism for spectral separation at an average spectral switching rate of about 50 milliseconds. The two systems, the two illumination platform then basically illuminates the target, and the reflected light is acquired by a scientific CMOS camera that has a 5x5 megapixel format. We characterize the imaging capabilities of the system, and we were able to reach a field of view of about 1 by 1 millimeter, which is suitable for small animal imaging and small animal models. And we also reached a spatial resolution of about 228 line pairs per millimeter. Then we tested preliminarily the camera on the exposed cortex of a mouse during a hyperoxic stimulation, so with a breathed oxygen level of about 85%. The preliminary results show the hemodynamic changes in the exposed cortex in the desired field of view. So first of all, we were able to spatially resolve micro and major vasculature in the brain, which is in the range between 50 microns and 100 microns. And also the quantification of the hemodynamic change was consistent with the expected hemodynamic response. So an increase in the relative concentration of oxyhemoglobin per unit photon path length during the hyperoxia stimulation, and a decrease in the deoxy concentration during the same condition. So for the future, we would like to further test this system on a more controlled environment, so in particular using liquid phantoms to effectively assess how reliable the quantification of the system is. Thank you for your attention.